This is SolidWorks Animation 0 to Hero. And as you can see, we're at Bengaluru Urban for the third time this time. And just a quick note. So if you guys don't know, I just checked my followers on LinkedIn and you guys came second. So you're really special. As Prasad said, you were the first place for me to give this webinar presentation, but you also the second most country to or city to follow me. So that definitely says something about the SolidWorks user and SolidWorks community over there. And I'm not going to talk a bit about myself because Prasad, I believe, has already done a great job about that. But let's just get into the topic of today and see what we're going to talk about. So we're going to start about motion studies in general. And we're going to talk about the different types of motion studies that are in SolidWorks. And then we're going to delve into each type of them in a bit more of detail. And at the very end, we're going to talk about the next step after making your animation in SolidWorks, how to export it, and a couple of tips and tricks regarding your exporting process. So first things first, why use motion studies? And the first thing that comes to mind is because it's eye-catching. Because if I'm scrolling on Facebook or LinkedIn and I see a post, for example, if it's text, so only a couple of letters and sentences, I might scroll past it. If it's an image, that might get my attention a bit. But if it's an animation, I'm definitely going to see what that is. I'm going to stop and look at it. So that's the first thing, that it drives attention to whatever it is that you're posting. And therefore, as soon as you grab the viewer's attention, you can now show him and tell him more about what you're designing. The second thing is that, for example, if you look at this on the screen, most of you might not be able to know what that does or what it's supposed to do. But as soon as I show it as an animation in motion, now you know that this mechanism, for example, converts rotary motion to oscillatory linear motion and that kind of stuff. So that's the point I'm trying to make, which is animations are probably the only way for you to show your models in motion. The other way is probably taking a screenshot every now and then, but that's not viable and that's not an easy way. It's not as eye-catching, return to the point number one, as animations. And the third thing is, if you want to show your model from angles. So for example, if you look at this on the screen, saying Yahya, and from the other side, it's saying Hid. So if I was showing this to you as a CAD file or maybe a screenshot or an image, you won't be able to see it from the different angles. But when I show it as an animation, now and only now, you can see your model from different angles. So these three things are probably the main things that I come to mind for me personally when talking about animation. Okay, and the last thing is to have fun, because why not? So for example, this video right now, this was made in SolidWorks 100%. Let's take a look. So all of this video was made in SolidWorks. Nothing was made in any other software. So knowing that you've got this capability in the software and knowing that you've got 1, 2, 3, or maybe even more ways and tools to make your animation, the ceiling is, there is no ceiling. Your imagination is your ceiling at this point. All right. And now we talked about motion studies. There are different types of them. And the main two types of motion studies are animation and basic motion. There's another type, which is motion analysis, but that's only for users that have SolidWorks Premium. So we're not going to talk about that today. So the main differences between animation and basic motion is animation is based on key points or motors. So let's talk about key points. Key points, you can think of them as still frames in time. So for example, if I've got my phone over here at time equals 0 and my phone goes over here at time equals 2. So here, that's a key frame. I tell the software, preserve this phone at this location at that time. And here's also a key frame. Yeah, what the software does is it does something called interpolation, moving it from here to here. This moving or transition is all done by the software, and you can change it or edit it, but it's 100% done by the software internally. The other way is using motors. So in this case, you just define some parameters and tell SolidWorks to run those parameters on your model. On the other hand, basic motion is more like simulation. So you're defining physical properties, you define context between components, you define gravity, for example, and you put in some parameters for those physical properties and let it run that simulation for you. So the main difference here is that when it comes to simulation, you've got motion analysis, as I said, but it's a bit computationally expensive, or it takes a bit toll on your device because it needs a bit more calculations in the background. But when it comes to basic motion, it's like a small bit of what motion analysis can do mixed with a small bit that animations can. So at the end, you get something that's fast and quick, but still gives you physical results. So to conclude, what the main difference is, when you're using animations, you know everything that you give it to the software. You tell it, I want this to do that. And then you just run the animation and it just moves from one keyframe or from one frame to another for you. On the other hand, in basic motion, you just tell it the main parameters, you define the main parameters of physical properties and let it run the animation for you. All right. So let's talk about animations in a bit more detail right now. So there are tons of techniques to use when using animations, as you can see. And let's start by key points, because that's like the basic thing. And the first thing is basic dragging. So let's say, for example, we want to make an animation of this. You might have seen this before. It's a chocolate trick where you cut it in different pieces and start rearranging them, and then you get what's supposed to be a never-ending piece of chocolate. But as you see in the animation, at the very bottom, you see that the chocolate actually got a bit smaller, but when you see that on camera without that border, you don't really see that. So let's say, for example, we want to make that animation in SolidWorks. So let's open the part real quick. And remember, now we're going to do it with just basic dragging. So even if your model has any mates in it to preserve the relations between components and each other, you're not going to use any of that. We're going to start by making a new motion study. And from there, as you can see, this is the motion manager, which does all the animation work inside. So as you can see here, we've got the time. So now we're at time 0. And this thing I'm dragging, this is what preserves or tells you where exactly you are at right now. So for example, if I drag this first key point over here, so now I've defined that my animation is 2 seconds long. And if I stop at any point in the middle, that's the frame where I'm at right now. So for example, at the 0 seconds, everything is as you can see right now. And maybe after 2 seconds, I want this part to be moved all the way down. So I'm just gonna drag it like that. And as you can see, what you've got over here, this rhombus looking thing, this is the key point, which tells you that over here happened a change. And that change bar, which is in green, tells you that there's something going to happen, which is interpolation, as I said, from this one to that one. So if let's just click calculate and see what happens. As you can see, it now does a transition between the first key point and the last one. And if I stop at any time in the middle, as you can see, it changes accordingly. Yeah, I can hear you. Yeah, we can talk about that at the end of the presentation. No worries. No worries. So now, for example, after I changed this and moved it a bit down, let's say, for example, after another 2 seconds, I want to change it a bit more. So I'm just going to drag it over here. And as you can see, it adds another key point and so on. So for example, over here, I want to drag this, for example, to the side, or maybe I want to drag this once again all the way down. So maybe something like this. And the next step is obviously going to change this. So I've got a mate here that prevents that from happening. So what I'm going to do is I'm going to suppress that mate, which is this one. And as you can see, if I suppress something, this bar, as you see over here, which is in orange, now it's disappeared. So this may, for example, is not going to be activated at all. Maybe I want to activate it at a later point. So for example, if I want to go over here after 2 seconds and unsuppress this, what you see is that it was disabled beforehand and now it's going to be applied to the model. So using these key points, you can start changing the properties of your animation and the position of everything. And let's get back to over here at 6 seconds and drag this over here as well. So as you can see, we've also got another key point and so on. And I can go on and on and on and try to make the animation perfect. But and I mean, no matter how precise I try to be, there's still going to be a bit some inconsistencies here and there. And that's not really a viable way to make your animation. So even though basic dragging might be a bit easy and fast, but it's not as if you're making it with mates. So let's try and do it with mates this time. So when I'm using mates, I'm talking about mates that have a value that can be changed. So for example, if I've got a limit distance mate, which has like a value which is going to move from, or maybe a limit angle mate, those kind of mates which have values are pretty awesome to use in your animations, because now instead of just doing that, I can just say, okay, I've got here a limit distance mate. So for example, I've got this mate. After 2 seconds, I'm just going to double click on this mate, and it tells me, yeah, it's a limit distance mate, and I can change the value. So for example, I want to change it to 40. If I click rebuild, as you can see, I've also got that change bar, and the part moves and so on. So based on this, I can start changing where my model is along the animation. So for example, I want to change it, let's get this all the way at 6 seconds. And maybe I just want that change to start after 4 seconds. So if I drag that original key point over here, so it's not going to change at all of this time, and after 4 seconds it's going to start to change. You can do anything you want with these key points, but make sure that you're entering values correctly. And if you can use numeric values using mates, that's way better and way more precise than using just dragging components by hand. And I can keep doing this on and on. So for example, I've got this limit distance mate. So if I get over here and also edit the value of it, as you can see, I can also input a different number. So for example, I want it to be like this. And you'll see that the component also starts moving accordingly. So based on that, I can go ahead and make all the animation, but using numeric values. So now I've got way more control on my animation. So the second thing that you can use key points to do is not just moving your components around, but also moving your camera around or moving the view around. So for example, let's take a look at this. In this animation, what we try to do is look at this model from different angles. Some of you might already notice that this is the logo for Adobe Reader, if you guys know that software. But the real neat thing about this component is if I look at it from a different angle, you see that it's not how you expect it to look at. So I want to convey that in the animation. I want to show to people that this model looks a bit weird from other different angles. So how can I do that? Of course, using animations. So most of you will do this. They're going to go and create a motion study. Let's just create a new one real quick. And remember, I'm now even inside the part, so I don't have to create an assembly to animate my model. I can do that inside of my part as long as I'm just changing views and that kind of stuff. And over here, let's say, for example, after 2 seconds, I wanted to look from this direction. And after 4 seconds, I wanted to look from this direction. So as if it's doing 180 degrees around. But you're going to notice that there is no key points being added. And that's because if I right-click on orientation in camera views, there's here an option called Disable View Key Creation. What that means is that it allows you to start moving around and viewing your model from different angles without preserving that view into your animation. In our case, that's not what we wanted to do. So we're going to disable that option. And when I get over here and start changing it, as you can see, now I've got a key point added. If I get over here and change it one more time, there's another key point, and so on. And if I start playing the animation, as you can see, it starts moving from one key point to the other. But the issue here is that I don't have much control. So for example, let me just delete that over here and drag it back here. And instead of this, I wanted to do something like that. So, and I want to zoom in maybe over here. All right. So that's what I'm trying to do. Make that all along the 4 second mark and hit play. As you can see, I don't have really much control over how it moves from one key point to the other. I only can tell it the starting position and the end position and how it looks, but I don't really have much control. And that's where cameras come into play. So if I get over here to the display manager, and from there I go to scenes, lights and cameras, and right click on camera and add a new camera. You can think of a camera as a way to look at your model from different angles. So now we've got a split screen. On the right, this is what the camera is seeing. So it's that rectangle over here. And on the left, it's what the model is looking like. So this red dot over here, if I change that, that's where the camera is looking. And this yellow dot, if I change that, that's the position where the camera is looking from. So by changing those, I can start precisely setting where the camera is and where it's looking at. And the best thing is you've got numeric control over here. So if I just hit check on show numeric controls, now I can say exactly where I want everything to be. So for example, I want it to be at 0, 0, 0, for example. You've got it. Or maybe you want it to be at the origin. So I can just select the origin, and as you can see, it's going to be fit exactly at the origin at all times. No matter how you change this, it's always looking at the origin. The same also applies to the camera. So for example, if I want to say that the camera has to be maybe 10 centimeters away, and the longitude and latitude. So for example, if I want to look straight dead on from the front, it's going to be like this. Maybe I want to be like 25 degrees up and 30 degrees to the side. I've got full control over what the camera is doing. I've even got control on the camera rotation. So if I want the camera to tilt to the side, I can also do that as well, as you can see over here. So all of this is done numerically, as you can see. And what's more important is that I've got control over things I can't do without using cameras. So for example, if I want to change the aspect ratio, or for example, if I want to change the lens of the camera. So right now it's using like a standard lens. I can change it to a wide angle lens. Let me just hit OK and look at that. So as you can see, it's a very wide angle. If I change, if I edit the camera and change it to maybe something different, for example, the telephoto lens, as you can see, I'm now zoomed in. I'm not really changing where the camera is. All I'm changing is the type of lens that's added on top of the camera. And as I said, we can also change the aspect ratio, for example. So if I want it to be like 1:1, I can do that. Let me just bring it back to standard, for example. I can also change it to be like 16:9, which is usually for most laptops and TVs and that kind of stuff. And now I'm going to hit OK. And I've got my camera. Okay, right. And down here, it says camera 2, which is indicating that you're right now in the camera view. And what this does is that now if I go ahead and create a new motion study, now I can use that camera inside of my motion study. So let's say after 2 seconds, I want to go over here to lights, cameras, and scenes and edit this camera. So let's change its properties. And now I've got full numeric control over everything. So for example, now I want to look at it from like 0 degrees. And over here, let's make this like a 90, for example. I want to look at it from the top. And maybe I even want to change the camera lens. So let's change it to like wide angle, for example, or maybe telephoto so that we can zoom in a bit and hit OK. So now if I play, as you can see, it's changing from one orientation to the other very quickly. And if I wanted to go back to the first position once again, I'm just going to copy this key point. So I just hit Control-C, and after 2 seconds, I'm going to hit paste. So now if I play it, and let's just set it to loop from over here. So now it's going to keep playing. So it goes to the top view and comes back again to the 3D view, and so on. And just like that, I can now change everything I want in how the model looks and from where I'm looking at it. And for example, as I said, interpolation isn't 100% based on the software. You can also provide it with some inputs. So for example, if I right click on here and hit interpolation mode, the default is linear. So for example, if it's like 0% over here, and after 1 second, it's 100%. So every 10 milliseconds, it changes 1%. So it's a linear scale, but you can change that. So for example, if I want it to be snap, what snap does is that it stays the same all up till the very last frame and then changes. So let me just delete that one real quick and play it from the beginning. So as you can see, it doesn't change. And at the very end, it starts changing. Let me get this back to normal. As you can see, it didn't change. So it doesn't change, doesn't change. And at the very end, it changes. That's snap. maybe we want to do something else. So ease in or ease out, or maybe ease in and ease out. So it starts slowly and speeds up at the end, or maybe starts quickly and does like a very quick beginning and then slows down at the end. You can change everything over here. So say for example, I want it to be ease in. So it's going to start very, very slow, and then it's going to go very fast at the end. So very slow, and then it goes very fast. As you can see, I can do this with all the keyframes I'm using. So back again, if I copy this and paste it over here. Now, if I change this and make it, for example, ease in, ease out, and get this back again to loop. Now what you're going to see is that it's going to do it very smoothly. Okay, all the way over here, because this one isn't easing in, so I can also change that as well. So maybe this as well, ease in and ease out, and let's play from the beginning. So it goes very smoothly and comes back again very smoothly. And now I've got a smooth animation that's not based on linear movement, and it's also not based on like moving the camera or the model around with your with your mouse or with your keyboard. Now I'm basing everything on numeric values. So now we talked about how to change the model itself and how to change where I'm looking at it from. Now let's talk about appearances. So now what I want to do is change what the model looks like. So for example, if I've got this model and I want to show that it's got some internal components that look a bit different, and I want to show that in my animation, I'm going to start a new motion study. And from here, what I'm going to do, let's say after 4 seconds, I want to change, for example, that top part, I want to change it to be transparent. So I'm going to get over here. So I'm just going to select it. And from here, I'm going to change transparency, for example. So it's going to be a bit transparent, and that can be animated. So let me just calculate. And as you can see, it starts like 100% opaque, and then its transparency starts getting less and less and less all the way till it gets fully transparent at the end. And I can do that, for example, for the bottom part as well. So for example, if I get over here and change the appearance, for example, here I've got full control over what that model looks like. So I can say it's not blue, I want it to be green, for example, and I want to change to green. So it starts blue and then changes to green later on. I can do that as well. So let me just get green over here and hit OK. And I've also got another change bar. And if I hit play, as you can see, it starts blue and then changes to green at the very end of the animation, and so on. And everything is a key point. So obviously I can right click, change the interpolation mode. So for example, I want it to be ease out, for example, and maybe I want it to start only after 2 seconds. I mean, the options that you can do with just key points is limitless. You can do tons of stuff with just using key points. And as you can see, I've changed my model. So now the top is transparent and the bottom is now green. I can even change the orientation as well. So for example, since I've already got a camera, let's change the camera as well. So let's use what we've learned in the previous part. So maybe I want to look from down, for example. Oh no, I've got a better idea. Let's look from the back, like that. And maybe I want to reorient the model so it's a bit centered in the screen. And let's just reduce distance from the camera and hit OK. So I'm now building up multiple different changes on the same model. And as you can see, it changes the camera, it changes the transparency, it changes the appearance of some components, all in the single animation. So now that we've talked about key points and how we can use them to change stuff in the animation, the main issue with key points is that you've got to define everything. So as I said, when you're using animations, you provide the software the inputs, and the software already calculates the transitions or the interpolations between each input and the next. But maybe say, for example, you wanted to tell it, do this and just leave it be. So for example, if I've got a tire or a wheel and I want that wheel to keep rotating over and over again, it's going to be pretty hard to do that with just key points. So what we can do this time is use motors. So there are 2 types of motors in SolidWorks, just as there are 2 types of motors in real life. You've got linear and you've got rotary. So let's say, for example, we want to make this animation. Obviously, you can do this using key points. So for example, if I want this red part to be moving up and down at the very beginning of the animation, I'm going to set it to be, let's say, like 30 centimeters from the base. And at the very end of the animation, I'm going to put another key point where it's at the very bottom of the base. And the software is going to do the interpolation for me. But let's say I want to do it differently. I want to do it, instead of defining key points, let's see what other options we can do using motors in SolidWorks. So here's the model, and the model is already set up so that when I change the this piston, the spring already gets rebuilt and like changes according to the piston. But that's not what we're here about. We're now talking about how to model this, or how to animate this movement up and down. And if I go to a new motion study, and this time I'm going to come over here to motors, and I'm going to add a motor. And the cool thing is that SolidWorks knows what you're choosing. So for example, let me just look at it from a different angle like this. And I'm going to choose a linear motor. As soon as I just select this, as you can see, the arrow is pointing up. So now SolidWorks knows that you want it to move up and down. But in this case, I want it to do downwards. So I'm just going to flip the direction. And I want it to move relative to this container. And now, when I define the speed or the movement of the part, I've got tons of options. So I can set a constant speed, which is like velocity. So for example, 10 millimeters per second. I can also set it for distance. So I tell it move, let's say, 30 millimeters, starting from the 0 time and ending in 4 seconds. So now it's going to move 30 millimeters in 4 seconds, and I don't have to tell it that 30 over 4 is 7.5, so I've got to move 7.5 millimeters. I can just tell it where to start and where to end and when to do that. And if I hit OK, now let's stop it at 4 seconds, and now let's hit calculate. So as you can see, as it's moving through, it's going to go and move those 30 millimeters for me. And I didn't even have to set what the velocity is in this time. Obviously, it's going to take a while to calculate because of this deformation. But as you can see, it's done the changing for me. And at any point in time, it's going to change for me. So what else can I do using motors? So let's just edit this motor real quick. And let's say I want to go up and down, like as expected from a spring. So instead of choosing this, I can choose oscillating. So this is an oscillatory motion, as you can see. So for example, I wanted to move the same 30 millimeters. And when it comes to the frequency, so for example, as I said, I wanted to do it in 4 seconds. So as you know, frequency is 1 over the time. So in this case, the time is 4. So 1 over 4, that's 0.25. And that's it. I'm just going to hit play. And instead of just going down in 4 seconds, now it's going to go down and then up in 4 seconds and keep doing that over and over. Okay, so now let's just recalculate the model. And as you can see, it goes down in 2 seconds and then up again in another 2 seconds. And I didn't have to set it to go down and then tell it again to go up. No, I just set one motor, which is an oscillatory motor, and it does everything for me. So let's just stop it over here and see what it does. So as you can see, at the 4 second mark, it goes up, and at the 2 second mark, it's down, and it's going to repeat this for as long as the motor is turned on. So say, for example, 4 seconds, I don't want the motor to be on anymore. I can just right click over here and say off. And now the motor is off. So at these first 4 seconds, it's going to stop moving. After 4 seconds, it's going to stop moving. And I can do anything else at the background, changing camera views, changing the appearances, and so on. Anything that we've worked on in the past couple of slides. So now we've talked about linear motors or linear actuators. Now let's talk about rotary motors. And this is the model that we're going to work with. And this model might not be a bit intuitive. So I've got a chain that I want to move around this part. Obviously, it's an imaginary part, but I'm going to drive it in a different way. So this red part is mated to this top plane of this light blue wheel. And if I rotate this light blue wheel, as you can see, the part starts moving along with it. Obviously, that's not the correct way to change anything in a chain animation like this, but the software will do whatever you tell it to do. So that's what we're going to do right now. We're going to start a new motion study, and I'm also going to add a new animation. And this time, the new motor is going to be a rotary motor, and I'm going to specify this blue part. And let's change the direction this way. And right now, this isn't connected to anything, so I don't have to choose what it has to move relative to. And for example, the constant speed, let's say I wanted to choose, so 60 RPM is like 1 second. So 30 RPM, that's 2 seconds. So I want to do one full rotation in 2 seconds. Now let's drag the animation only to 2 seconds and zoom in a bit. And now let's have calculate. And as you can see, it did that for us. So if I stop at, let's say, 1 second, it did 180 degrees, and at 2 seconds, it did a full 160. And the options that we just saw using the linear motor, they're also here. So if I just edit this rotary motor, and let's say, no, I don't want to set it at constant speed. Maybe I want to set it at segments. So segments, here you tell it that you've got multiple transition periods. So for example, it's going to start at 0 degrees, and in 1 second I want to go to 180 degrees, and then after from 1 second to maybe 3 seconds I wanted to go to 360 degrees. And here I've got graphs for velocity and displacement and acceleration and everything, and I can even change the segment type. So for example, if I wanted to be linear for the first part, and for the second part I want it to be, let's say, a half cosine. So this is based on mathematical equations, and let's hit OK. And let's hit OK once again. And this, as you can see, is 3 seconds. So let's drag the change to the model to the beginning and run this animation and see how it's going to move. For the first second, it goes linearly, so it does 180 degrees in 1 second, and then it changes to 2 seconds per 180 degrees for the rest of the animation, as specified in the rotary motion. And right now, I just did like a very small example. You can do this with any sort of changes or interpolation modes inside of your motor as you wish. So that's about motors. Pretty much you've already got like 80 to 90% of what you can do with animations with just using motors and key points. But SolidWorks is extremely generous, and it's got another tool in animations for you. So that tool is the animation wizard, and it does pretty much as it says. So it's a wizard. How? So instead of doing something and doing it in like 10 or 15 steps, SolidWorks can make you in 1 or 2 clicks do that same thing. And that's the thing we're going to try is rotation. So for example, if you've got a model and you want to rotate it 360 degrees, let's see how we can do that. And before I start, I'm just going to open my clock real quick because I want to do a counter. So let's just reset this and see how fast can I make a 360 animation of this model. You ready? 3, 2, 1. Done. 7 seconds. In 7 seconds, I've got my 360 animation. And before I play it, let me just turn on real view and turn on the shadows. And let me just hide the background, the floor appearance. And turn off reflections as well, because I don't like how they look. So now I've got my my model, and it's got the shadow dropping on the floor. Now let's look at how the model looks like. So as you can see, though I did create a 360 animation, the weird thing is that it's not doing it correctly. It's moving from the top and the bottom. So over here, I'm looking at it from a bit high, and let's say midway over here, I'm looking at it from the bottom. That doesn't make sense. And let's think from another perspective. You see this y-axis? So when creating this animation, I set it to rotate around the y-axis. Now take a close look at the y-axis. It's rotating itself. So I'm supposed to be rotating about it, but what's happening is that even the y-axis is rotating with me. So that's obviously not what we want the animation to do. But as you said, as you know, in just 7 seconds, I created animation. So if you want something very quick, you can do this. But in my opinion, you should never use the animation wizard to use to create rotation animation. And I'm gonna to show you right now how to do that. But before that, let's just talk a bit about how this even works. So if you notice, we've got a couple of key points down here, and these are all orientation key points. So what it does is that you know that option that we disabled, it's as if it undisables it, so it enables it, and then it starts moving around. So after 2 seconds, it gets to this point, and after 4 seconds, it gets to this point, and so on, all the way till it gets back again, and then just plays these key points, or plays the transition from one key point to another. And the issue here is that, say for example, I want to change this from 0 to 10 to, like, say from 0 to 5. So what can I do? I've got to, let me just zoom in a bit and drag this to 1 second, drag this a bit over here, and start dragging these key points all the way to where they have to be. And if I drag something incorrectly, I'll have to change it for myself. So for example, here, it's not really at 5, it's a bit before 5. So let's right click, edit key point time, and say exactly 5, and so on. Now I've got it from 0 to 5, but that's still not an easy thing to do, because let's say I've got a big animation that needs to be changing, or for example, it's not just in 5 seconds, maybe I want it to be in 2.5 seconds. How I'm going to do that? So it's not that easy. And there's something else, which is when I'm creating the animation wizard. So let's get back to it over here. And as you can see, I'm choosing the rotate option, rotate model. So I can choose whether it's around the x-axis, the y-axis, the z-axis, clockwise or counterclockwise, the number of rotations, etc. And I can also specify when it starts and how long it's going to be for. So for example, I want it to start at 0 seconds and make it, let's say, 8 seconds this time. So it was only 5, now I'm choosing 8, I'm gonna hit finish. And now it's just chaos. So it just added some more key points to the animation. So let's just play it this time. And now it's just chaos because I still had the previous animation, which the key points didn't get deleted. So it's just a mix between the previous one and the current one. So instead of doing that, there's an option to delete all existing paths. So if I choose that and recreate it once again, what it now does is it deletes everything I had before and adds the new key points to the animation. So that might solve the issue, but there's another problem over here. So the issue right now is, let's just delete everything. So I'm just going to start from a blank animation. So there's nothing going to happen. And let's say after 2 seconds, I want this component to be hidden. So let's just make this transparent. And after another 2 seconds, let's make this transparent. And maybe I just changed a couple of more stuff about the animation. And now I want to add my rotation. So I'm going to go to the animation wizard, and I'm going to set next, and make it for 5 seconds and hit finish. Now I've got my animation. If I play it, it's going to do the rotation, and the components that I specified are really being transparent. Now, if I want to change it to something else, so I want to change it to, let's say, 10 seconds. So as you saw, we can delete all existing paths and do it for 10 seconds. So I'm just going to start from 0, and the duration is 10, and hit finish. So everything looks perfect until you start scrolling down and you realize that it also deleted all these key points that I've also added at the rest of the animation. So now if I hit calculate and play, there is no animation happening to the transparency of these components. So I've lost all the other stuff I made. And right now I just had 2 key points. Let's say, for example, you made a full-blown animation and now you're starting changing stuff. And then, oh, I realized that I want to change the rotation from 5 seconds to 10 seconds. And I delete all paths, all of the animation is gone. So that's obviously going to be something devastating that no one wants to happen to. So instead, I've got another option for you, which is to do it manually using cameras. So what I've got over here is I've got a plane. So let me just look from the front plane over here. So I've got a plane a bit above my model, and on that plane, I've sketched a circle. So let me just show that circle real quick. So I've got this circle that's sketched on a plane on top of my model. And now what I'm going to do is I'm going to go here and add a new camera. And I'm just going to show the numeric controls. The target, I want, let's say, the origin. The origin is a bit low, so here's a nice tip. If you want something to be relative to that origin, I just turn this off. The y-axis, let's say 125 millimeters. So now I'm off in the y-axis by that, so I can mix and match between my choices. And now when it comes to the camera position, instead of defining a value, I'm just gonna select this this circle that I've drew. And now I've got a slider. And what this slider does is it moves the camera along that path that I've selected. So as you can see, now it's at 100%, and now it's at 0%, and here it's like 180 degrees around the model, and so on. And this doesn't have to be a sketch. So for example, if I, instead of selecting this, let's select this edge, for example. It's okay. And now it's going to move along that edge. So it can be anything, a model edge, a sketch, a line, an arc, a spline, whatever you want. But in this case, I'm just going to select this one and set it to 0%. And for the aspect ratio, let's make it 1:1, for example, and hit OK. And now I've got my animation. So back again to the animation we had. The issue here is that I'm not starting with the camera view visible. So I'm not in the camera view right now. So what I mean by that is if I'm over here and I'm already in the camera view, if I start a new motion study, it's already inside of the camera view as well. But if I already had a previous animation that isn't in the camera view and I want to start using the camera view, what I can do is I can just right click on this. So you see orientation and camera views, the first key point. What I'm going to do, of course, I'm just going to delete all these key points first. I'm just going to right click on it and choose camera view. And now it's going to start using the camera view that I've specified. All right. So now all I have to do is change the value that I've set for the camera. So let's say after 5 seconds, let's double click on the camera and change this slider from 0% all the way to 100% and hit OK. And now I've got a perfect 360 view animation of my model. And you know what's even cool is that if I want to change this, so for example, it started as, let's say it's 5 seconds. Let's just do it real quick once again. So here I'm going to slide this all the way to 100%. But the changing is from 0 to 5. If I want to make it 10 seconds, I'm just going to drag this over here. And now it's going to be in 10 seconds. Oh, wait, I want to be in let's say, any arbitrary number. So I'm just going to right click on this. And instead of even changing anything in the camera, I'm just going to change this key point time. So instead of 10 seconds, let's say 3.75, any arbitrary number. And now what it's going to do is it's going to do that one full rotation in whatever time you specified for the software. So using this, you can now ensure that the animation is linked to numbers, so you can easily change it and modify it along the way. And it's also way cleaner. And, you know, let's talk about the main thing. You see this y-axis over here? So now let's take a good look on it while the animation is running. So as you can see, the y-axis is right where it is. It's not moving at all. I'm rotating around the y-axis. So therefore, I'm sure that this is working perfectly, unlike the other one. And here is both of them side by side if you're still not convinced. So the one on the right is the one using cameras, and the one on the left is the one done using the animation wizard. And I'll leave you be the judge for which one you would like to use. So yeah, maybe it took a bit more time to do the one on the right, but I'm pretty sure that the results are totally worth it. Okay, now back to what we were talking about. Let's talk about exploded views. Most of you already know about exploded views and know how to create them in SolidWorks, I believe. So if I've got an exploded view for this model, let's just turn off real view graphics. I don't need it anymore. if I go to configurations and open this default configuration, I've already got my exploded view over here. And some of you might know that if I go over here, I can animate the exploded view or the collapse of my model. But the issue here is that I don't have any control over anything except just the speed. And let's say, for example, I hit save over here. It's just going to save an animation of this model being exploded or collapsed. Let's say, for example, I want to use my exploded view in my animation. So, for example, I want to animate the explosion. I also want to animate, let's say, components changing their colors, or components appearing and disappearing, or maybe even change the camera views. So to import this inside of my animation, what I'm going to do is, let's just get back again and collapse it. And I'm going to create a new motion study. And here from the animation wizard, since I've got an exploded view in this animation, I've got these two options as well. These weren't there before. They were grayed out because I didn't have an exploded view in the other model. But here, if I hit explode and hit next, so for example, I want it to be exploding in 6 seconds and start at the very beginning, and hit finish. As you can see, it's went ahead and added all these key points for me without me even having to do anything. And now if I hit play, it starts animating the exploded view inside of my model. And just as any other key point animation, I can get, let's say, at the 4-second mark and change the transparency of some components and maybe change the camera view. So if I get over here and let's just disable the view key creation and look at it from a different angle. So for example, let's say let's show the cube, and I want to look at it from over here, for example, and maybe it's just zoomed in a bit like this. Okay, I've got my key point. Now let's turn off the cube and hit calculate. So I've just used the exploded view inside of my animation and changed other things as well. Or maybe I want to do both. So an explosion, and after a couple of seconds, so get over here, wait for 1 second, and then collapse the animation again. So I can also do that here in SolidWorks. But I'm going to start after a couple of seconds. So here I wanted to start at 7 seconds. And maybe I want to collapse a bit faster. So in 3 seconds only, I've got total full control over everything over here. So now if I play the animation, it's going to explode in like 6 seconds, wait for 1 second, and then collapse in 3 seconds really quick. So as you can see, I've got all these key points that I can change as I want to. So maybe, for example, I want to select all of those and drag them a bit far away like that, or maybe get these two real close to each other. Any changes that I do over here, these are changes to key points, just as any other key points that you added yourself. All the difference here is, instead of you going ahead and adding these by yourself, the software just does it for you. And now let's talk about the last thing, which is mate controllers, which unfortunately I don't see many people using, even though it's a very powerful tool in SolidWorks. Maybe because it was added recently, not that recently. So it was added, I believe, in 2016. So it's not that far away as well. But what it does is, just as the name implies, it's a mate controller. So it controls mates, but it controls them in a very fast and quick way that you might have never seen before. So let's just take a quick look. If I go to insert and go to mate controller, it's going to start a new mate controller for me. And what I'm going to do is now select the supported mates to control in the mate controller. Or I can just click on this button, which is going to collect all the mates that I have that are supported by the mate controller. And we're going to talk a bit after a while about what types of mates that it supports. But for now, I've got these 16 mates, and these are actually renamed by the way. So if I get over here and open my mates folder, these are all limit angle mates, but I just renamed so that I can know which one I'm using. So let's get back again over here, and let's look at the model from here. And what this mate controller does is that it gives you numeric control over all of the mates that you selected. So now at position 1, everything is at 90 degrees. Let's go over here and add a new position. Let's say position 2. And what I'm going to do is like change these all to 0, for example. So I just changed everything to 0. I'm just going to hit on update. So now I've updated the second position. And let's say, for example, I want to add a new position. And let's say, for example, I want this to be here, this to be here. Let's change a bit more. So maybe these like this, these like this. I can change anything I want. And now I've got this mate controller that has everything I need. So if I edit it, and let's say I want to export a video right directly from it, I can do that as well, just as we did with the animation wizard when we use the collect or explode animation from over here. So for example, the first position to the second position takes 2 seconds. Let's say the second position to the third position, that's done in only 1 second. I can change that as well over here. And if I hit on calculate, it's going to calculate that change for me, as you can see. And all I have to do right now is just hit save the animation, and everything is going to be changed for me. Or what I can do instead, let me just change this. So let's say I want to get back to the first position as well. So I've got 1 and 2. Yeah, I hear a question. Is someone asking anything? All right, let's keep going. So if I want to duplicate this first position, I'm going to start at it, and I'm going to hit on a new position. And even though I was at the first position, it's still going to add it at the very end. So when I've got the first position, the second position is everything down, and the third position is everything up. And if I want to edit that even more, if I click on this button over here, it's going to help me reorder all these positions. So I can delete, I can move things up and down, and so on. But let's just keep things simple right now. As I said, I want this to be in 1 second. And let's say maybe this in 0.5 seconds. So I want it to be a very quick animation, something like this. And we're done. All I have to do now is just hit OK. And this mate controller is saved for me. And I can change the different positions by over here, like that. So if I go back again to the first position, like this, let's say I want to import this into my animation. So I'm just going to start a new motion study. And from there, I'm going to also go to the animation wizard. And right now I'm going to select mate controller. And I'm going to hit next. Which mate controller? So mate controller 1, because that's the one we just created. And I want to import it as key points. So remember, as I said before, we've got another third type of animation of motion studies called motion analysis. So you can also import it as motion analysis. But as I said, this session is only talking about animation and basic motion. So that's not really in the scope of today. And now, as you can see, I don't specify the duration. So the duration is grayed out. That's because I've already specified it inside of the mate controller when I said it's 1.5 seconds. All I have to do right now is just tell it when to start. So I want it to start at the very beginning. I'm going to hit finish. And as you can see, it's already 1.5 seconds for me, as you can see over there. So what it did is that if I open the mates folder this time, all of these mates have key points created for them. And if I hit on calculate, it's going to start changing that for me, as you can see. It's a bit too quick, so let me just slow that down a bit and play it once again. As you can see, it goes from the first position to the second and third and so on. And the cool thing here, there's the same thing I did with this animation wizard things, if I can also hide things and change the camera and everything that we can all build that up in the same animation. And the really neat thing is that you can do stuff like this, for example. So this is an animation wizard that I've created before. Take a look. So it shows these two armrests getting down and then getting up, and then it does this kind of wave motion. So if I want to do this manually, it's gonna take me like 1 hour of just pure typing in angles and values and changing this and changing that one by one. But when I'm using the mate controller, as you can see, it's all done very quickly and in no time. And I can even import it inside of SolidWorks, as you saw. So when it comes to mate controllers, the supported mates that we've got are these mates listed down here. So angle mates and limit angle mates, distance mate and limit distance mate. And we've also got the width mate, the slot mate, and the path mate. But in these 3 mates, we must choose something that is numerically controlled. So for example, in the width mate, you can't just choose the free option, which just moves it arbitrarily between the guidelines for you. No, you have to have something that's got numeric control for it. So whether it's defined by a dimension or a percent, either is fine. But as I said, it has to be done using numeric control. So that's all about animations in SolidWorks. If anyone has a question, we can take a real quick question before getting into basic motion. All right, so let's keep going. And if you've got any questions, we can still hear them at the very end. So now let's talk about basic motion. And as I said, basic motion is more of physics based. So it's a bit like simulation, but you're defining some real life phenomena like gravity, like context, that kind of stuff. And the software simulates that for you. So let's take a look at what we're trying to achieve right now. So for example, if you want to make an animation like this one, so we've got a bunch of balls falling and then they get sorted into this turntable. So to do something like this, we need, first of all, the balls to fall down in the animation. And that's what we're going to start with right now. So let's start by adding gravity to our motion. And the first thing that you're going to notice is gravity is a bit different in SolidWorks. So in real life, gravity is always pointing downwards. But since this is software, you can simulate it doing anything. So what I'm going to do is I'm going to start a new motion study. And over here, I'm going to go to gravity, which is right over here. Now, if I select that, it tells me right away that you're choosing something wrong. You're still in animation mode. And as I said, you have to be in basic motion or motion analysis to use gravity. So all I'm going to do is just hit this drop-down menu and just select basic motion. And now I can specify my gravity parameters as I want. The direction, it can be any arbitrary direction I want. So for example, if I want to go in along this edge, for example, let me just select this edge. And the direction you can see over here at the very end. So it's okay. Let's say swap the direction. So it's going this direction. It's fine. Or maybe I want it to be more realistic. So in the Y direction, but instead of going up, I want it to go down. So I can also change the value. The default value is obviously the G of Earth, the gravitational acceleration, but you can also change it to, let's say, the gravity of the moon or any arbitrary value you want to use. So I'm just going to hit OK. And now what I'm going to do is hit calculate. So I've got the balls somewhere at the top, and I want to see how are they going to interact with my model. So there's nothing actually going on, but if I stop moving frame by frame, I can see that the balls are actually moving, but they just go through my model. They don't interact with anything. So even though I've got the gravity component correct, what I don't have right now is contacts. So I have to make these components collide with each other and stop each other from moving. This animation is actually a bit computationally expensive, so there's a lot of contacts in here to be calculated. So I've got another model to show that on. What we're gonna do right now is use this model, which most of you might have seen before. So it's a machine that shows you different types of waves at the same time. So we've got like sine waves over here, which is that type of transverse waves, and over here we've got longitudinal waves, and all of that is achieved by just rotating this this rod. So obviously you can do this with animation. If you apply, let's say, a cam mate or a tangent mate between these components and each other and rotate this rod, it's going to work. But let's just say for now that we want to make it like a simulation. Okay, so I'm going to start a new motion study, and I'm going to go from animation to basic motion. I'm going to remember to change that. And first things first, since I want this to rotate, I'm going to have to add a motor. So let me just choose the motor and zoom in on the rod over here and select that. And let's just change the direction, let's say this direction, and moving it relative to the body. And for the speed, let's say I wanted to do one rotation in every, let's say, 4 seconds, so 15 RPM, and hit OK. So right now, without doing anything, if I just hit calculate, it's just going to rotate and nothing is going to happen because I still haven't specified any contacts between the components and each other. So as you can see, it's rotating, but let me just turn off the mates that I had added before. So I've got these tangent mates, I don't need them. So I can just suppress them all real quick. Let's hit suppress. And now none of these will take effect. So if I now click on calculate, this rod is just going to rotate on its own and nothing else is going to happen, as you can see. So now if I want to add the contacts, what I'm going to do is specify which components have to interact with each other. And to do that, I'm going to go over here to contacts, as you can see. And what I've got here is the option to specify what contacts are going to collide with each other. And it's going to tell me how many contact pairs are there. And keep a real good eye on that because we're going to come back to it later on. So what I want over here is everything except for the body and the rod. So just these circles down here and these rods over there. And let's see how many contact pairs. So I've got 561 contact pairs, and that's a bit too much. So if you think of it, it's as if this rod is being calculated against every other component, and then the other one is calculated against any other component, and so on. Now let's hit OK and run the animation. And as you can see, now the rods are starting to move along with it. But the issue right now is that the rods are just moving, pushed up, and there's nothing bringing them down. So what we need this time is to add gravity. So let's go ahead and add gravity once again to this animation and make sure the direction is correct. And now if I hit calculate with contact with the motor and with the gravity, everything should be working just fine. So as you can see, rotating the rod with using the motor causes everything to move just perfectly as we intended. Right, so let's get back to here to our slides. And the thing is, when we talk about contacts, as I said, we had tons of contact pairs, like 500 plus. So trying to reduce that, we have to use something called contact groups. So what contact groups do is they group components together that won't collide with each other. So for example, in this animation, these discs, they don't seem to be colliding with each other at all. Neither will these rods ever collide with each other. So all I want to do is, if a disc collides with a rod, then calculate the contact between them. Otherwise, don't calculate it. So to specify that, what I can do is I'm going to just delete this solid body contact, and I'm going to add, once again, I'm going to add a new one. But this time I'm going to choose the use contact group option. And now I've got two groups. So in the first group, I'm just going to select all the rods. So here they are. And in the second group, I'm going to select all the circles. And now if any rod just happens to collide with another rod, it's not going to calculate that. It's only going to simulate anything pink with anything light blue. So before I just end it, let's just real quick see how many calculations it's going to do. So if I just edit it real quick, I've pushed it down to 289. So it's a bit like half the previous number. So that means it's going to calculate way faster than before. So let's now hit calculate and see how it goes. As you can see, it's way faster than the previous time, and it's going to give you pretty much the same results. And it's done. So just in a couple of seconds, we've changed the animation to be less computationally expensive and use less resources of your device. And if you want to see them both side by side, here they are. So on the left, you've got the ungrouped contact, and on the right, you've got the grouped contact, and they pretty much the same. Both of them, there's no visible difference between them. The only real difference is the solving time, how long it takes to solve your animation. And if I want to like compare it with mates, so if I'm using animation instead of basic motion, so the left is the one that's using basic motion, and the one on the right, that's the one using animation. And you might notice that the one on the right is a bit smoother because obviously it's not calculating any real physics. So there's no contact between components being calculated. There's no gravity. There's nothing like that. But it might look better, but it's not realistic. So for example, if I want to take more things into consideration, like friction between components, and taking into consideration that this component is made of this material, therefore it may slide a bit harder or slide a bit smoother and that kind of stuff, that you can't easily do using animations, but you can easily specify that if you're making, let's say, motion analysis, you can specify everything in the contacts and how the components interact with each other. Okay, so now that we've talked about your animation or your basic motion, your motion analysis in general, now let's talk about the next step. So after you created your animation, now it's time to export that animation. And there's a couple of points to take into consideration. The first thing is just never hit next, save. You're not installing a software. Pay close attention to everything you're doing. That's because it changes according to what you're going to use the animation for. So first things first, as you see in both animations on the screen, the one on the left and the one on the right, the model itself is changing throughout the animation. That's something that you can't accomplish unless you're using animation. You can't do that with motion, and you can't do that with motion analysis. And why? That's because in animation, on every single frame, the animation is being rebuilt. The whole component or the whole assembly is being rebuilt. Anything that changes is going to be rebuilt. So therefore, you can have components like the spring that I showed earlier in the session. So that spring was being rebuilt on every single frame to give you that change in geometry. But remember, even if you're making an animation, but you're rendering it with PhotoView 360, for example, or let's say SolidWorks Visualize, you can't animate any geometry changes. So geometry changes is only limited to animation that's being rendered by SolidWorks. No rendering by external software will give you that geometry changes at all. The next thing is that you're not only limited to exporting as videos, so you can also export your animation as frames, so as images. So let's say, for example, you've got 1 second animation that's 30 frames per second. Instead of saving as a video file, you can save it as 30 different image files. And it's pretty useful if you want to use them, let's say, to create a GIF, for example. You can take those, edit them, change some properties for them, you use some photo editing tricks on them, and then create an animation from them. And the next thing is resolution and FPS. And I usually find most people using these things incorrectly. So they just use the defaults from SolidWorks, and the defaults are not always the best. So for example, the resolution is how wide to high how high the image is. So for example, most videos should be like full HD, so 1920 by 1080, or let's say HD, which is 2080 by 720. So that gives you tons of pixels to use in your animation, which is big and bright. But an FPS is how many changes are viewed to you throughout the animation. So for example, if I've got like 10 frames per second, so that means that you don't see any changes happening in between. But if I've got something like 30 frames per second or even 60 frames per second, then the animation is going to be very smooth and you're not going to notice any choppiness at all. And the last thing is video compression. So video compression, it's about how the video is exported from SolidWorks and what codec or what encoding is used to export that video. And that doesn't really change what the animation does, but it changes how it looks like, because it changes first the quality of the video at the very end, and it also changes how long it's going to take exported. And based on these, the file size of your animation also changes. So let's just take a look real quick. So here I've got an animation I'm going to show you real quick, and I've got 3 different types of video compression to compare to. So on the very right, we've got MP4. In the middle, we've got a fully compressed AVI video, and the very left, we've got the uncompressed AVI. Let's play them. And remember, anything weird you're seeing, that's 100% in the video file. That's not because of the internet connection or PowerPoint. That weird things you're seeing on the screen, that's all because of the different codecs or different exporting compression that we're using. So obviously it's a big deal. So you might create a wonderful animation, but because you chose the wrong way to compress it, it looks a bit like the one in the middle. So let's take a look right now on how to improve something like that. So here we've got the part, and I'm going to go to the motion study. And first things first, I'm going to go over here and hit save. And the default thing is in an AVI file format. So let me just go to my desktop real quick. Okay, so here you've got the file format. So we've got AVI, FLV. All of these are video formats, and series of these are all image formats. So series of bitmaps, series of JPEGs, PNGs, and so on. So let's say, for example, I want to do it as an AVI, and I want to now specify the aspect ratio, which is the ratio between the width and the height and the resolution. So I can change that from over here. Since I'm using a camera, I can use the camera aspect ratio, or I can just choose a custom aspect ratio if I want to. So for example, let's say 16:9 or 1:1. And in that case, if I change anything of these, the other number is also going to change accordingly. But right now, let's just use the camera aspect ratio. Let's say something a bit big so that it's good. And now let's talk about this. So you see the 7.5 frames per second? Never use 7.5 frames per second. It's very choppy. So for example, it's looking like a robot. Like, it's very choppy and it's not smooth at all. So let's say 24 or maybe 30 frames per second. All right, and now let's hit save. But before I hit save, I only want to export this animation from 2 seconds and so on. So anything before 2 seconds, I don't want that to be exported with me. So what I can do over here is frames to output. I can change it to a single frame, for example, if I want to export just a single image, or a time range. So in this case, from 2 all the way to 6.1. And now I'm just gonna hit save. And now it's going to ask me about the video compression, which I'm talking about. So here in the compression, this depends on the encoders on your device. You've got full frames, which is uncompressed, which is no compression at all, or you've got this compression quality, which you can specify. So 85% is the default. If you go 0, that means that it's going to do the best compression ever. So it's going to compress it at the very end. 100%, the least amount of compression at all, and 85 is something in between. And let's just hit OK, for example, and now it's going to go ahead and animate that model and save it as a video file. So if I look at it real quick, here's the video. All right, it's saved to my desktop. But now let's try something else. Let's say, for example, I want to save it once again, but instead of an AVI, let's say I want to save it as MP4. In MP4, it doesn't ask you for the quality of the codec, the compression, anything of that. All you have to do is just specify the aspect ratio, the frames per second, and hit save, and it just goes ahead and does it for you. So nothing else you have to do. All the compression is handled in the behind the scenes. And let's try the third thing, which is, let's say, for example, a series of images. So if I go over here and say I want it as a series of PNGs, for example, okay, I'm going to say like that. And now what it's going to do, let's say PNG, I'm going to hit save. What it's going to do is going to save a series of PNGs, one for every single frame I've got. So for example, if I let it go all the way for like a half a second, that should give me 15 frames. So let me just wait till it goes to half a second as I hit pause. So that's it. And if I look, I've got these 15 frames. These are all PNGs, as you can see, all still images of my animation. And what's really cool about PNGs is that, if you don't know, PNGs can support transparent backgrounds. So if you go over here to the options, and from there you go to your export options, as we see together. So if I go to export, and from there I choose these image formats, now I can select the option to remove the background. And if I hit OK, and let's try this once again, so also let's save it as a PNG, and also like that. Let's say PNG, no background. Right? Let's say save. It's going to do the same thing, but this time there won't be any background. So all this dark gray that you see in the background, that won't be included in the image. And now let's see how that is going to look like. So as you can see, all of these are now with no background at all, as opposed to the previous ones, which had a background to them. All right, so now let's just delete all of those real quick. And back to our compression over here. So now we've seen the different results from the compression, but we still haven't talked about the file size. So this is what you get in file size. So the one on the very right, that's the MP4, and it's 23 kilobytes. Remember, kilobytes. The one in the middle, which is the fully compressed, which looked like garbage, that's 1.5 megabytes. So we're now talking about a different scale. And the one on the very left, which is the uncompressed AVI, that's a bit like, it's more than a quarter of a gigabyte. It's like 300 megabytes. It's insane, the difference in file size between these three. Even though the one on the left and the one on the right looked similar. So I don't believe any of you actually found any differences between the one on the right and the one on the left. But still, the difference in file size is massive. It's just huge. Okay, and remember, all of these are the exact same video. They're all 4 seconds long. But I mean, imagine just saving a 5 second long or a 4 second long animation and realizing that it's 300 megabytes. Try uploading that to YouTube or to LinkedIn or Facebook. It's massive. So in that case, what I'd suggest to you is choose a better or even a more quality performance perspective. From the quality perspective and performance perspective, I believe that MP4 is the one to go. So it gives you better quality, it gives you smaller file size, and you don't even have to think about what compression to use. You're just going to select MP4, hit save, and it does everything for you. So in conclusion, AVI, if you're going to use AVI, you must take compression very seriously, and you must consider it, and you just can't choose any number and hit OK, because as you saw, it really does change how the animation looks. On the other hand, SolidWorks, when it exports MP4, it neglects all of that. Everything is done in the background, and it just gives you a perfect example for the real balance between file size and video quality.